Hello everyone. I welcome you all to the e-videos prepared for Anna University syllabus under the regulation 2021. Today we are going to see the session on process synchronization from the second unit process management in the course CS 3451 Introduction to Operating System. Myself Dr. C. Rani. Let us see the objective of today's session is to know about the process synchronization. And the outcome of the session is to know the students may be able to understand the process synchronization. So here is the outline of today's session. First, we'll be seeing about what is meant by process synchronization and what is meant by race condition problem. And to overcome this race condition problem, we can solve it using producer-consumer problem, which is otherwise called as bounded buffer problem. So let us see what is process synchronization. Before moving to the process synchronization, we'll see what is data inconsistency. Process synchronization means more number of processes will be executed on the CPU in an ordered fashion. That is called as process synchronization. So each process, for example, process P1, P2, etc. goes on up to P1. So more number of processes will be executed and these processes will be communicated to each other by means of message passing model or shared memory model. So on the basis of synchronization, the processes are categorized into two types. The first type is independent process. The second one is cooperative process. What is meant by independent process? That is the execution of one process which does not affect the execution of other process. That we call it as independent process. So one execution of the process should not affect the other execution of the other process. It's called as independent process. What is meant by cooperative process? The execution of one process that will affect the execution of other processes means that we call it as cooperative process. So in the process synchronization, we have data inconsistency problem. We'll see how the data inconsistency occurs. Okay. So cooperative process is one that can affect the other process execution, or a process that can be affected by other processes executing in the system is called as cooperative process. This cooperative process can either directly share a logical address space, that is both the program code and the data, or it may be allowed to share data only through the files or messages. So the concurrent access to the shared data, that is many users can share the data in a simultaneous manner. That is concurrent access to the shared data will cause the problem called data inconsistency. So to overcome this data inconsistency problem, various mechanisms are available to ensure that the orderly execution of the cooperative processes, that is, it can share the logical address space so that the data inconsistency will be maintained. So to overcome the problem, we'll move with the bounded buffer problem, or otherwise called as producer-consumer problem. So here the buffer, there will be a buffer of n slots. This we call it as the buffer. Okay. So having n number of slots, each slot is capable of storing 1 unit of data. There are two processes running, namely producer process and the consumer process, which are operating on the buffer. So always the producer process will write the data into the buffer and the consumer process will read the data from the buffer. So buffer is a queue. There are two processes running. One is the producer process, the other one is the consumer process. The producer process tries to insert the data into an empty slot of the buffer. The consumer tries to remove the data from the filled slot in the buffer. The producer must not insert the data when the buffer is full. For example, if the buffer gets completed, that is, if the buffer contains full data, the slots are full, means the producer process may not be able to insert the data into the buffer. And also another case, the consumer process may not remove the data when the buffer is empty. That is, if the buffer is empty, there is no other data is filled in the buffer, means the consumer process may not be able to remove the data from the empty buffer. Okay. So the producer and the consumer should not insert and remove the data simultaneously. So if the producer and the consumer problem or accessing the shared data will lead to the problem called data inconsistency. So if you want to maintain the data inconsistency problem, it will require a mechanism that we need to ensure that the execution of the cooperative process in an orderly manner, ordered fashion. If we execute the cooperative process in a ordered fashion, means we can maintain the data consistency. Okay. So the consumer producer problem will have the solution while maintaining the buffers. A bounded buffer is maintained in which multiple producer and multiple consumer will share a single buffer. Okay. So always the producer process will write the data to the buffer and the consumer process will read the data from the buffer. So two things we need to have to focus, that is the producer process will block if the buffer is full. Okay. Consumer process must block if the buffer is empty. Okay. So in the producer consumer problem, an integer variable, that is count, that keeps track of the number of full buffers. Initially, the count value is set as 0. The count value will be incremented by the producer process after it produces a new buffer. And the count value will be decremented by the consumer process after it consumes the buffer. Here is the producer which produces the buffer until the size is full. That is, until the buffer reaches the full size, the producer process will keep on producing the buffer. Okay. So while the condition is true, the producer process will produce an item and the count will be incremented. Okay. So inside the while condition, there is another while condition need to be satisfied. That is, if the count is equal the buffer size, that is, if the buffer is full, we cannot do nothing. Always the producer process will write the data into the buffer. Okay. So the buffer is full. The producer cannot do nothing. Okay. If the buffer is not full, it can go on, write the data into the buffer. That is, in means input. Buffer in means input. The next producer process will get produced. Okay. After that, the buffer size will be incremented after producing the producer process produces the buffer. And also the count value will also get incremented. So in the producer process, if it produces the buffer, it goes on producing the buffer until the buffer reaches the full size. In the meanwhile, the buffer size will be incremented and moves to next producing process will be gets continued, and also the count value will also increment. Coming to the consumer process, always the consumer process consumes the buffer until the size of the buffer gets 0. That is, until the buffer gets empty, it is go on consuming the buffer. Always the consumer process will read the data from the buffer. Okay. So while the condition is true, again, it is checking for the count value. If it is 0, that is, if the buffer is 0, empty, then we cannot read any data from the buffer. That is, do nothing. Okay, buffer out. So if the buffer is not empty, the consumer process can read the data from the buffer. At that time, the buffer size will be incremented by 1 and the count value will be decremented by 1. So we can move on consuming the item in the buffer until the buffer gets empty. So the race condition is explained here. The situation where several processes access the same data or manipulate the shared data concurrently means the race condition will occur. The final value of the shared data will depend upon which process finishes last. For example, you can see the picture here, process 1, process 2, process 3. If 3 processes are sharing the same data concurrently means the race condition problem occurs. So to prevent the race conditions, we need to synchronize the process, synchronize the concurrent process. That is, the concurrent processes must be synchronized in an ordered fashion. Okay. So here, as we have seen earlier, a separate portion for the producer process as well as the consumer process. The count is a variable which is an integer value which is incremented during the producer produces the new buffer. Okay, produces the item in the buffer means the count value will be incremented. This is implemented as the registers 1. Okay, that is, count is a variable or a data which is shared by both the producer and the consumer process. If the new buffer is produced, the count value will be incremented. If the buffer is consumed, then the count value will be decremented. Okay. So high-level code will be converted into the machine-level code because the CPU understands the machine-level code. Okay. This increment of the count value is implemented as the count value is assigned to the register 1. And the register 1 value is incremented and stored in the register 1 variable. And the value of the register 1 is again moved on to the count value. In this manner, the count value is incremented when the producer produces the buffer. Okay. And the count value will be decremented and it is implemented as the count value is maintained in the register 2 and this will be decremented and stored in the register 2 and the register 2 value will again stored in the count value. In this manner, the decrement of the count value is implemented. Consider the situation interleaving with the count equals 5 initially. See here, the producer process execute the count value. So initially, the count value is 5 means the count value 5 is assigned to the or stored onto the register 1. And the register value is incremented by 1. The register value now becomes 6 and it is stored on register 1. If the consumer process execute means the count value, initially the count value is 5. So the 5 value is stored onto the register 2. Consumer process execute register 2 means then it is the register value will be decremented. From 5 minus 1, it is decremented to 4. So that value is stored onto the register 2. Okay. And if the producer process execute, the count value is coming to the producer process, the count value is 6. And coming to the consumer process, the count value which is stored in the register 2 is, the count value is 4. So which is not equivalent. Okay, initially the count is 5. We have two different values. When it is stored in the register 1, the count value is 6. And when it is stored in the register 2, the count value is 4. So we get the different value here. This is the problem of race condition. The two processes, producer and the consumer, accessing the same data, same shared data concurrently means some mechanism need to be followed. We get this incorrect value because of both the processes execute concurrently. Several processes access and manipulate the same data concurrently, and the results depend upon the particular order in which the access takes place, which is called as a race condition. To overcome the race condition, we need to ensure that only one process at a time can be manipulating the variable counter. So two process, producer process and consumer process cannot access the count value at the same time. So to make such a guarantee, we require that the process be synchronized in some way. See here, the two processes P0 and P1 is there. Both the processes simultaneously calls the fork system call. So fork, we'll be using this fork system call for creating the child process. So for each and every process, there will be a process ID will be assigned. Here the process ID is 2651 is assigned to both the children. So that should not be happened. So the child of process P0 is also assigned the PD value as 2651. And for the process P1, the process ID is also assigned the same value. So that should not happen. So to overcome the race condition, we need to take care, that is the producer and the consumer process should not access the count value at this in a concurrent manner. These are the references used for preparing the slides. Thanks for watching.